here. 100% infield. Huge thing here. This is also on island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm tube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. Hey, Macandraga, Tro Firelight, Irib, Francis Bellon. Yes, exactly, Francis. Forrest. Thank you guys for joining in this half an hour late live stream. Sorry, I went to bed very, very late yesterday. I prepared the day before. I didn't sleep that much because I prepared a big presentation. I had a big presentation yesterday from 8 p.m. to midnight. And then at midnight, I had a phone call from midnight to, I think it was around 2 to 3 a.m. And then I thought I was going to sleep. And then at 3 a.m., I had another phone call from 3 a.m. to 5 something. And then I finally went to bed, I think, at 5:30. And I put many alarms, like 8:20, 8:30, 8:40, 8:45, 8:50 for the stream at 9. And none of them woke me up. The one that woke me up is the baby. So very, very useful to have a baby to wake up every 3 hours to check. But it's inaccurate. The alarm baby is inaccurate. But anyway, I was thinking, maybe should I postpone the stream to tomorrow or something? And then I remember, the warping stuff and the motion system, and I was really excited about learning about that. So that excitement make me go quick and prepare the live stream in less than 4 minutes, I think. Late, I think you're just on time. Yeah. Thank you. Similar to a cat alarm. Yeah, I've never had a cat, so I don't know. I've had dogs, but I never had a cat. So okay. So let me prepare some stuff here because I went live, but I didn't prepare everything. So let me do. Actually, I never prepared the giveaway. So let me put the giveaway first. Just to bring some awesomeness in the stream as always. Kind of create the vibe of awesomeness. I think I'm gonna pass on the alarm baby at this moment. Yeah, every 3 hours, right? If you don't feed it early, the alarm is gonna start. Is it morning for you right now? Yeah, it's it's 9:40 a.m. 9:40 a.m. My kids are 13 and 16, so I wake up before them. Yeah, at this age, yeah, it's the opposite. We become the alarm for them, right? Giveaway, I'm tired. Yeah, I don't know if, yeah, hopefully it's let me stretch up a little bit, and then we'll get started. Hi, epoxyjewelry.com. Okay, so today, although the title say motion system, first we're going to check. We have a new members in the PRINTBUSTERS community, and this new member come from, if I remember well, I think come from V3D, I think. Do you remember we had the live stream where we were talking about the cauliflower, and then we talked about we tried to understand what was the cauliflower, and then we joined their Discord, and then on their Discord they had some discussion around the stream, and I think he or she was in that discussion, if I remember well. And then we talked about shrinkage and stuff, and then obviously, as any topic, a shrinkage and stuff came to warping came to that debate. And then we talked a little bit too much on that channel, and then one of the mods said, you guys are great talking, but we were taking quite some space in the channel. And then we moved that to our Printbuster topic. And it happened that Resu is now actually quite active in our Printbuster community. So I really like when we have new Printbuster member, and I think he's been talking on the other channels, on the other topics as well. So anyway, on the warping topic, he came up with something which I haven't read yet. I want you to keep that for the stream, so that we discover together his a new input on some of the question we had for warping. And also, I think he had a good point. Is it's very difficult for newcomers at the moment to catch up on the warping stuff. So he made me write something to make it easier for people to come. But I think the easiest, instead of asking where warping come from, I think a better question, if you guys are going to Printbust a little bit on some other forum, I think the better question is, what makes a material warp more than another? And I think that question is much better than where warping come from, because usually is where warping come from. You don't even know material shrink and expand with the temperature, and then but how does that is related to, with warping, and then blah blah, and then coefficient of thermal expansion and blah blah. So in order to skip all of this, then if you are going to Printbust in some other forum, just ask directly, hey guys, I'm struggling understanding warping, and do you guys know what makes a material warp more than another? And I think the answers you're going to get from that might be a little bit better than just asking, like I did before, just asking where warping come from. We should look at the SnapMaker motion system if you have time. I just got one, and it's very interesting. Yeah, we have time. Like I said, after we check this, the warping stuff, then we'll just go full motion system. And apparently even motion system itself, there were some different definition on the channel. I thought it was all about linear rail or ball screw or anything that moves, or like the belt, but apparently it's much more complete than that. So we'll definitely spend some time on this. And like I said, for all the new one, not the new one, for all the people that already know motion system, then maybe this stream is going to be a little bit boring, because for me, I literally know nothing. I mean, apparently Core XY is part of motion system, and I'm happy that I already spent hours on understanding that. But we'll really go back to the basics. So are we going to play any game today? No, I didn't. I literally just woke up, so I didn't prepare any game. We are going to play the learning game if you want, Michael. Quick off topic. Could you please look at least at my newest direct message on Discord after the stream? I finally won a giveaway, but I'm afraid something went wrong. Okay, yeah, I can do that. Actually, I'm seeing on stream that you have sent me a message. I will check that. I've been a little bit late. Like I said, yesterday night and today we have the global sales meeting, and the last 2 weeks I've been preparing these, and that's why I've been busy. So after tonight, I'm free. I mean, I'm free. After tonight, I'm less busy, so I'll be able to catch up on a lot of things. And I'm starting catching up by calling some people already. Cameroon from LDO, thank you for being awesome. Nicola, I bought the 3D Printing Failure 2022 book, and your material science is absolutely amazing. Oh, awesome. Nice. Yeah, that book is amazing, and I'm very proud to have been invited to write a chapter in inside. It's been a long time. It's been I think 2 years that I've wrote this chapter, because it was for the edition 2021, and I didn't have time to update it for 2022. And but I really want, with all the work we have been doing together, I really want to update that chapter. And I won't write my name anymore. I will write Print Buster from Polymaker instead of my name, because I think all the knowledge that sorry, because I think all the knowledge that I've been gathering really come from what we were doing. So I think if I happen to update that chapter, then I think I will put our name like Printbusters from Polymaker, and I think that's going to be awesome. So now I know where's warping come from. Michael, one disclaimer. Like I said inside, I said the origin of warping is still well, I don't know how I formulate that, but I say the origin of warping is still debating, and here's my take on that. So that's really my hypothesis on warping. When the polymer crystallize, they shrink slightly. Yeah, so that's for semi-crystalline. For amorphous, I have a different explanation in the book. Are we going to start with make a deck? Well, I had the make a deck on screen just now, but this is more for Saturday. We're gonna do our printer practice. Well, actually, you know what? Now that I have it on screen, I really want to try very quickly, very quickly. Yeah, I failed this one. I don't know. And the 3v2. Quick. I think this is Anycubic Viper. And then very quick. I don't know, kind of Prusa Mini. And then Voron, and then Focus, and then that's, we did it already. And then what is this one? And then Flashforge Adventurer. Okay, so that's my really quick printer printer practice. But anyway, I was catching up here first. FDAF patch, it arrived, but not the one I wished for. We should do a LDO giveaway. Oh yeah, what? Yeah, LDO giveaway. Good evening, everyone. Hey, Peslis. Yeah, Peslis. I woke up late. I woke up 30 minutes late. Gesundheit. Thank you, Irip. Top right is Ender 3 Max. We will work on your printer knowledge. Yeah. Did I had a lot of wrong? Yeah, I think now they have. I think we can play the game with. I think they have some kind of command that you can quickly get the printer name. So I think if I do something like bang make Kieran Clark key Clark key. Oh, bang make or maker. Oh no, bang make maybe. Yeah, another thing is my messages somehow have been like, sometime I'm on Twitch and I send message and nobody received them, and I have no idea why. I already told Peslis about it, and okay, so latest meg blah blah CRC. Yeah, you see, so now you have all of these printer, but I think they were working on something as well. I don't remember. Setup Peslis, latest setup, blah blah. Yeah, so there's bank setup and bank made, but anyway, I like to play that game in order to get a little bit better at recognizing hot end and printers and stuff. We will work on your we have bank setup. Bank setup. What's the difference? Hi Hi, Kieran. Paisley's latest setup is fucking Odin 5, iPhone 7. Oh, okay. So one is make, like what? Huh. Zombie is really using Galaxy Dark Blue like all the time. He's not only recommending it, he's like using it also all the time. But anyway, now you have access to more information, so you can play game sometimes I like to play game on recognizing the filament or recognizing the printer, or well, maybe not the iPhone, or I mean what's the camera, but what is make a deck? That's my line. Hi everyone. I wonder why Paisley's, yeah. What is LDO? 10 more, but we need to check into that. We make motors, but also foreign printer. Yeah, Cameroon from LDO. If you want to do some, if you want to give away some, well, I'm thinking about it. Like, I think the best would be if you are an engineer, or there is some engineer from LDO that would like to come in PRINTBUSTERS, that would be great. I was thinking about if you have some stuff to give away, but I'm more interested in if you have some people that would be interested in coming into the stream and explaining to us some stuff about hardware. That would be more valuable, I think. I mean, a giveaway is nice, but what if we can learn, like, for example, stepper motors? Like, do you remember you guys told me there is brushed stepper motors and continuous and blah 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 blah, and we still didn't check what's the difference between all of them. That would be so awesome. Why not both? Yeah. We could do both also. Yeah, Mechadek was on Prusa, but unfortunately, I didn't see it. I need to check. I don't know. I guess it was a presentation of Mechadek or something. I need to check. Creality has like 5 printer head with the Neo one, and like 20 printers with weird combination. Yeah, but we need to practice. We need if we practice, then we're going to recognize all of them. Explain the hardware, then give it away. Yeah, that would be nice also. Okay, let me get back to you about getting an engineer for future stream. Oh yeah, that would be awesome. That would be awesome. If so you guys are making hardware, right? And I think one of the main thing you make is the stepper motor, and you are doing kits. So we are going to talk about motion system also today, and I'm pretty sure I guess you are making also some of those parts. That would be so cool. Prusa Live, their podcast. I'll send you the link. Yeah. So I got these for my Core XY. How do I put my own printer on MakerDeck? I think you can bang something. Let me check. Is there some command? Submit request to stream into. Yeah, here. Let other maker know. Submit request. Submit a request to stream into this feed. And then I guess if you click there, then they will explain to you what to do. And then apparently it's a form, so I guess you have to submit a form. Woo! So you have to read this, and then submit, and then Paisley's will I guess Paisley's will deal with that. Oh yeah, bang join there you go. Okay, so how about we have a look at that warping stuff? Okay, let's go. I was just waking up by reading a little bit the chat, so that my mind is warmed up before we get into that. Okay, so again, we were talking about warping, and then I went through the usual stuff about why and why and why and why, and then finally Resu stepped back a little bit, and then think about the discussion, came up with something, and then came back and then wrote a nice thing about warping, and that's the thing I wanna check with you guys. So okay, here we go. The data the data does back it up. So in the stream, there was a question if the thermal expansion value of PLA and PC are similar. Why does PC show more warping? I even used a lower thermal expansion value for PEI and still predict higher warpage based on my model. Okay, so his hypothesis is to explain why a material would warp more than another one. So his hypothesis is that when the hot bead is laid on top of the cold layer, the temperature does indeed even out. Okay, so when you print one layer on top of the other layer, then the other layer is going to absorb some temperature from the layer you just laid down. I mean the bead that you just laid down. But there is still a temperature gradient, okay, which cause more stress to be deposited in the material laid on top. Okay, so this has to be defined where that stress come from. The temperature does indeed even out, but there is still a temperature gradient which causes more stress to be deposited in the material laid on top. Okay, so you know what? Let me open my wonderful PPT. I think what he means is that a temperature gradient would create stress. So he's not explaining why a temperature gradient creates stress, but my guess is, so let me put my beautiful layer first. So you have a layer, right? And then what he's saying is that when you put another layer, then here it will be hot, and then the top layer bottom and the top layer top would be the same temperature, and then the bottom layer bottom will be colder, and then you have a gradient, and that temperature gradient for some reason will create stress. My proposal is that we should be looking at the thermal expansion from deflection point downwards only. Okay, so that's very interesting, because you remember that this hypothesis was given by two other people. The YouTube video that was talking about, that was the graph and stuff, that we said that the graph is impossible because the cool down and the heat up didn't join together. So he was saying that we only count the stress or the shrinkage after TG, which is basically the deflection temperature. I think he's talking about the heat deflection temperature, which for amorphous material is more or less TG. And then we had someone else, I don't remember, but in this channel that was also mentioning that. So it looks like his hypothesis go towards that. My proposal is that we should be looking at the thermal expansion from the deflection point downwards only. The reasoning is that once we reach the deflection point, the material is solid enough not to deform without affecting the layers below. Now, if we look at different, okay, so you get what he means. So this layer, which is being deposited, as long as he's above TG, above the heat deflection temperature, then it will be viscoelastic enough to just shrink and expand as he wants without affecting other layers. But once he hardened below TG, then it will want to continue shrinking, but he is already stuck to the layer below, so he cannot shrink anymore. So he start to create stress instead of shrinking. Then it's stressing the part. So far it makes sense in my opinion. Blah blah blah. Now, if we look at the deflection point of different materials and compare them against common print chamber temperature, we can see a clear correlation with expectation. Okay, so let me open that Google Doc. Let's go there. Let me open that Google Doc. Okay, so that's pretty nice. That you see how involved some people can be, and I really love that, because it's really helping, helping us understand. So if we look at deflection point, so HDT or TG, let's just say TG, okay, to make it easier, because that's for amorphous material, and compare them against common printer chamber temperatures, we see a clear correlation. So here we have material, okay, here we have heat deflection temperature, aka TG. Actually, if we see ABS, yes, TG, PLA, yes, TG, PET, well, PET, yeah, PET, it's I don't know if we consider it as amorphous material in this situation. So let's remove it. PEEK, let's remove it. Nylon, let's remove it. And nylon HDT 110. I don't know which HDT he's using. I don't know if it's so. Let's remove PET, PEEK, nylon, PC. Okay, PC, and PEI. Yeah, so let's say ABS, PLA, and the PC. Okay, so we have their TG. Oh, actually, there is the TG just there. And then the thermal expansion. Okay, so you do have PLA and PC that are similar, and you do have ABS that are the highest thermal expansion. And then our question was always, why PC warps more than PLA if the thermal expansion was the same? And then you have the print temperature. Okay, so again, PC doesn't have to be that big. You know, our PC TG is 110 and printing temperature 260. But okay, and then total shrinkage to various temperature from TG temperature. So you have 10 degree. Okay, so then he's total shrinkage to various temperature from TG temperature. Okay, so now he's calculating if you are, let me check. Total shrinkage to various temperature from TG. Oh yeah, so if you are 10 degree from TG, so which means 10 degree from TG, so which means 90 degree. So from 100 degree to 90 degree, I guess, then it's going to shrink this amount. And then from 100 degree to 20 degree. Oh, no. So what is she saying? Total various to temperature from TG temperature. TG minus temperature times the thermal expansion. Okay, so so that's the temperature. Oh, so that's the room temperature. Sorry, that's the room temperature. Okay, so if you print with 10 degree room temperature, then the shrinkage rate is big because the difference between TG and the room temperature is big. And then if you print at high room temperature, then the shrinkage reduces. Okay, and then he has for ABS, PLA. For semi-crystalline, it's hard to say because crystallization has so much to do with it. So let's just stay on amorphous, and then PC. Shrinkage rate total TG to TC. Okay. And then total shrinkage to various temperature from deflection temperature. Yeah, okay. So it's the same. It's similar. So okay, no problem. The upper graph there is showing expected thermal expansion from TG, which was my first guess. We can clearly see that the data doesn't correlate with what we would expect. Based on TG only, nylon would be more stable. Yeah, again, nylon is a semi-crystalline, so I would remove it from the equation. But we look at deflection temperature instead. We can see that the data shows a clear correlation to what we would expect. Okay, so now he's making a clear difference between TG and heat deflection temperature. So if we go heat deflection temperature and then PC and PLA in red and PET there. Okay, so basically, let me check nylon. Yeah, but I think he shouldn't take nylon because heat deflection because so basically here's what happened. I think he made the thing with the TG, okay, and then he realized nylon is warp less than PLA, okay, And then he went to try to find a different data that would make nylon warp more than PLA. But the problem is, in my opinion, nylon doesn't warp for the same reason. Nylon warps because it's a semi-crystalline. Nylon warps because of crystallization. Michael, if you have read the book, then it's in the book. So I think TG was great, and TG and HDT for amorphous material are similar anyway. So I don't think he should have changed his data just to make it. We don't try to find data that match the reality without explaining. You get what I mean? Like we you don't choose the graph that matched the reality and said that's this graph because it matched the reality. It needs to have some explanation. I think the explanation is clear, but that would be more for TG, not heat deflection temperature. The explanation is for TG, and I think it's clear. And so far, I think it's a great explanation. If you remove the fact that if you remove the semi-crystalline and if you remove the HDT. For example, printing ABS at about 50-degree chamber temperature shows similar amount of shrinkage as PLA in room temperature. Okay, so this is interesting. This is very interesting, which can be confirmed by observation alone. We can also see the higher chamber temperature needed for like peak for successful print. Again, for me, this is a different for semi-crystalline. Actually, this also shows another thing that is interesting. That is very interesting. If we look at the point where each of the material hits 0 in expansion, we are seeing the recommended bed temperature for those material. Yeah, I mean, that's normal because that's the, where it hits is the TG. So what he's saying is the best bed temperature is TG, and the best chamber temperature is TG in general. I don't know why he's talking about the bed temperature itself, but I think bed temperature or chamber temperature is the same. It's the point where the material loses structural integrity. TG, yeah, okay, as defined here. So let's check this link. Mario Hacker. What material should I use at high temperature environment? Blah, blah, blah. So let's have a look there. Whew. The easiest way to compare how well different material withstand temperature, heat deflection temperature, blah, blah, blah. Another factor to consider is the glass transition temperature. Basically, this is the point where the material begins to lose the ability to hold its shape. Below the glass transition temperature, the material will be rigid and brittle. If you bend it slightly, it will return to original shape. Above the glass transition temperature, the material will become progressively more soft and rubbery. If you bend in the deformation, it will be permanent. The glass transition temperature has another application in 3D printing. You will notice that this temperature is very close to recommended bed heating temperature for each material. This is because the material will not warp due to thermal contraction if you can hold it or above the glass transition temperature. PLA, the most common, has very low glass transition temperature. If you leave PLA on the print dashboard of your car, blah, 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 our normal recommendation with people, blah, blah. The glass transition temperature is also interesting because you can use it to gauge how difficult the material will be to print with. The glass transition temperature is the point where the print will begin to undergo internal stress due to thermal contraction. The further TG is from room temperature, the more plastic will shrink, blah, blah, blah. Yeah, again, my take on this one. But okay, so now let's go back to this. What do you guys think about this explanation? For me, that's not the first time that someone bring up that TG. And my answer is usually always the same. My answer is, if that's the case, if you print ABS at 230 degree or at 260 degree, the result would be the same, which for me, in my experience, and I hope in your experience as well, because I know you guys print a lot, that's definitely not the case. Depending on the printing temperature, you have different results. If you print ABS at 230, some ABS can still extrude at 230. Then it will warp like crazy. If you print at 260, then much less. So why is that? The TG is the same. The difference between TG and the room temperature is the same. But why does, so the follow-up question to that explanation is, why does printing temperature affect warping? Okay, and we have seen some research, right, of people printing at different printing temperature, and they had different warping results. It was a quick research. It was only five times three tests at different temperature, but we started to see a correlation. We haven't done an actual test, or actually I did with ASA, and even in our experience, I mean, it's very clear. Even if you print with PC, it's very clear that if you print PC at a low temperature compared to high temperature, then you will have different amount of shrinkage. And if you don't believe me, that's fine. You can challenge me, and I can do some print, or I can find some other research. If you don't believe that printing temperature affects the warping behavior. So that's my follow-up question. So I don't know if I asked this already, but because I didn't read that before. Yeah, so that would be my follow-up question. In that case, if it's only depend on from TG to so first I will clarify that he should remove semi-crystalline and remove the HGT, because I think it doesn't make the explanation accurate. But if you remove that, then it's very clear. Now the question, and it makes sense. That's the most important. It makes sense. However, does that answer the question on why the printing temperature affects warping? When I say printing temperature, I'm talking about the extrusion speed, which means printing speed and printing temperature would affect warping. Okay, so look at my photo just over this text. It's Polytera PLA. Oh, this one. What did you have any warping issue? Oh yeah, you did. Sorry, it's a little bit slow, but okay. Did you solve that? It looks like you're using the smooth PEI, no, from Prusa. I've heard some other people having some warping issue with Polytera with the smooth PEI. So I don't know if you flip it over whether it's going to be better with the rough surface. But yeah, I hope you solved your problem. Hi 3DHP. Did I answer you 3DHP? I don't remember. But like I said earlier in the stream, today is my last kind of busy day. So Zombie, yes, I found 4 200 bow screw, blah blah blah. Not trying to be smart or anything, but how much can you beat a dead horse about warping? What does that mean? Not trying to be smart or anything, but how much can you beat a dead horse about warping? Is that a phrase? Beat a dead horse? Does that mean like it means you talk about it a lot? Oh, okay. Yeah. Well, Zombie answered. Until I get an answer. I'm not gonna let go. If that's for sure. If people just wait that the topic is just gonna calm down and then we're gonna forget about it, then no, definitely not. As long as I don't have a clear answer and I clean up everything, then I'm going to talk about it. We don't have an answer yet. We know how to combat it, and we know it is temperature related. Well, Slim Pinkings, is that if that's good enough for you, then yeah, you don't need to beat the dead horse anymore. But I'm gonna beat him a lot, as long as he's not talking, and I want the answer from the horse. Yeah, it's smooth PI. Yeah, I've heard some customer having issue with Polytera PLA and smooth PI. So maybe try. I think it's smooth on one side and rough on the other side, right? Maybe you can try to flip it over to see if it's work better. Probably use glue with smooth PI. Okay, 3DHP. So yeah. I will get to that. I mean, I'm awesome. Okay, so yeah, definitely. I don't know. You are not frustrated by not knowing that. I mean, it's one of the biggest problem in 3D printing, and we don't even know. We don't even know what's happening. That makes me so frustrating. Uh, I don't know. If you are not, then stop beating this dead horse. Right? You can go and ride some alive one. It's a funny expression. Some people think you don't need an enclosure for ABS. You do. Layer adhesion and warping, lifting. Um, uh, 3D I think is all about. Um, so first, it depends on what theory you think warping come from. But from my theory, you don't need an enclosure in a way that you can solve that in some other way. If you're printing too big, then you won't be able to solve it. But if you print at a very hot, very slow, and a bit of a high layer height, then you will be able to obtain decent parts. Even layer adhesion is going to be good because layer adhesion is about polymer entanglement. So whatever, as long as your cooling rate is reasonable, then if you really understand, because I'm thinking I have a good understanding through my theory, so I can come up with a lot of ways to solve warping, and it has been working very well for me. Either it's just luck. My hypothesis is very close to another one, so that's why whatever I do is working, or maybe that reason, that root cause, is the real root cause. So that's why it's very easy to solve the problem. No, it's smooth on both sides, but I have the texture. Yeah, texture sheet. I'll test it. Yeah. Otherwise, go on the maybe post this on the Polyterra channel directly and see all, because there's a lot of users in the Polyterra channel that are using Polyterra, and maybe let's see if there is anyone using the same bed as you. It would be interesting to see the difference between an enclosure and a draft shield and how it affects strength warping. Yeah. I wasn't trying to be rude. Yeah, I know that, sleep picking. No worries. Just thought we talk about it a lot. I still love listening and learning. Yeah, yeah. I know sometimes even zombie get a bit annoyed by me being me. So I know that. I know that sometimes a topic can be a bit too much, a bit too horse deadly. Why a decent part, get a perfect part with an enclosure and a heated chamber is even better? Yeah, I agree, 3DHP. It's just that not everyone has access to enclosure or heated chamber, so that's why they also need some kind of ways to to print with ABS. Mark you of you. I was given a random ABS once. I guess I didn't understand very well because my big print in an open printer was a disaster and I threw the spool away. Yeah, a big print on an open printer is challenging. It would take forever to print if you wanna print it with decent quality, which I know is not good enough, but if you don't have enclosure. Hey, as long as you keep up with chat, I'm happy. But I'm the hardware guy. Yeah, you see, I mean, I keep it in chat, right? That was the last message. Okay, so that's my take on Resu hypothesis, and I will send a message to him. I will answer here the follow-up question, which is how to take in consideration printing temperature, and then his answer is going to be either printing temperature doesn't affect the warping. It's all about the TG and the room temperature, in which case I will have to find proof that it does. So I will link the research, etc. Or he is going to come up with another hypothesis, which I'm really looking forward, and then we can check that in the next episode of PRINTBUSTERS. Okay, so motion system it is. Big print on ABS is risky in general. Yeah, if you don't have a heated chamber, definitely. Garbage bag from Walmart is your enclosure, I guess, on a budget. Yeah, I usually prefer cardboard box. But yeah, garbage bags, why not? Numeric. Just a question: why Polymaker do not have our own 3D printer? Because we make filament. Yeah, because we make filament. It's like all the printer manufacturers. I mean, except Prusa. Then which printer manufacturer has filament? I mean, filament that they are making, right? Not filament that they are white labeling. So it's kind of the same question. Is because they make printer, they don't make filament. Cardboard enclosure for the win. That Amazon boxes need to be recycled. Yeah, FDAF patch. I'm the same. I prefer cardboard box instead of garbage bag. It's a lot of effort to make and sell a printer. Well, wait. Are you saying it's not a lot of effort to make filaments? What? They would need something new and unique. Yeah, that's another thing. Like, even if we want to make a printer, there's no point to make another printer that is kind of the same than other. If we want to make a printer, then it would have to be it would have to be it would have to be something that is bringing new things to the market, not a sightseeing. So IKEA bag for enclosure. Okay, maybe I can tape together enough Polymaker boxes to enclose a printer. Yeah, that's an option also. Filament is easy. You just melt a bunch of plastic and extrude it into a roll. Really, zombie? That's easy to make filaments? I don't think so. I don't think it's as easy as people would think. I'm not saying it's harder than printer. I'm just saying that you can get a good enclosure tent for 60-65 bucks. I'd recommend it to anyone printing a lot. Yeah. The market needs another i3 Chrome. I'm joking. We can get into making filament another day. Yeah, I know you're joking. Okay, motion system. What it is? What's the topic? What's going on? Okay. A whole new topic. Blah, blah, blah. Okay, so my thought about motion system was my thought about the topic was which of the different motion system is the best, or what's the difference between the different motion system. And for me, motion system was all about this type of thing, like linear rail. So what is the fire hydrant here? Fire hydrant. So, well, what? Am I a robot or what? Come on. Oh, linear rail. Okay, so for me, this is a motion system. Okay, and then you have how do you call that? Ball screw, I think. Yeah, and this is another different type of system, or this is another system, but apparently it's more than that. Those are elements of the motion system. Okay, so it's just part of the motion system. Generally speaking, the term motion system refers to everything but the tool head. Everything but the tool head. Well, I guess without the electronics as well, I guess. Currently, Mendel style is by far the most common. Recently, Core XY has been gaining a lot in traction though. Okay, so step number one is to list out the different motion system defined by what he just said. Everything but the tool head, and maybe remove. So you take a printer, you remove the tool head, you remove the electronics, and what else you remove? You remove the extruder, and you remove all the Bowden things. What else you remove? And I guess the rest is what we call motion system, right? 3D printer. Okay, you remove the tool head, you remove all the electronics, the power supply, you remove the screen, all the control, you remove all the electronics, the board, you remove the extruder. Okay, you remove all of this, and then what's left is called a motion system. So I guess we're gonna define it like this, right? Still looking forward to a stream or video from the lab or manufacturing my polymaker. Yeah. I need to go to Changshu and to our factories. But it's still in the plan. Just need to organize it. I made a few threads with information. Okay, yeah, we're getting there. I love my E3D tool changer. Core XY is the best in my opinion, although I only have i3 style. Yeah, most important is to define the why, right? Why Core XY is better than all the rest, if it's the best. Look at my info first. He won't read my comment, will he? Yeah, I'm reading. Cut part on your stream the other day. You really do have a voice for radio. I told you guys, Zombie has a very specific stream vibe. Okay, so you have a couple of things. Okay, so I've come up with a list of different motion topics: guiding components, motion translation, movement system. A list of different motion topics. Okay, so what are those? Guiding component. Guiding component. They are the component that guide a moving part along a stationary part. I like to consider them as reference plane because all motion move along that plane. Most guiding components work along a linear path, meaning the individual motion component move in a straight line in that plane. I'll start with V wheel, since that seems to be pretty common on entry-level printer. Okay, so this will be about guide moving part along a stationary part. Okay. So it's the connection between what's moving, what's not moving, basically. And then you have different, so you have the V wheel and then linear rods, which is used in Prusa. Okay, I understand. So let me get a full picture first before going into detail. So first you have, okay, so you're calling this guiding component. Okay, so if there is some people in chat that thinks there is more guiding components, then feel free to add it in this particular thread. And then the other is called motion translation. Motion translation. These are the typical way. By the way, Zombie, really nicely done. It makes finally a stream that is organized. Finally, a topic that is organized. I mean, I'm talking about me, right? These are the typical ways of converting rotational force from a stepper motor into linear movement. The first is timing belt. Okay. Is there some other way? Oh, yeah. And then the lead screw. Okay. Okay. So, okay, I understand. Guiding components, the connection between what's moving, what's not moving, like how to connect them. And then motion translation, how to translate the stepper motor movement from rotational to a translational. Okay, got it. So far, so good. Movement system. I list some of the popular movement system that use this motion component. The most popular is Cartesian. Okay. So movement system is what this guy was calling motion system. Okay, so that's the general That's the thing I was saying of you take a printer and then you remove all the stuff. I think the most popular is Cartesian, which uses one independent motor per axis, a typical application. Okay, Cartesian, and then Core XY, and then you have Delta, I guess, but only uses belt, blah, blah, blah. Okay. Understood. And that's okay. So that's the way we are going to organize our discussion around the pros and cons. So you have different guiding components, the connection, okay, and then the motion translation, and then the movement system. Yeah, I think it's very clear. I think it's very well defined, and yeah, I really like it. At least for me, it's extremely clear. Well clearer than it was 5 minutes ago. um, hey, non-fam, cut part of your cinema, blah blah blah. Matt German, thank you guys for joining. L out of order, thank you for being awesome. By the way, if I missed something or got something wrong, let me know. I don't know if there's anything wrong, but the structure for me is very good. I think it clarifies things very well. I had no idea how to name these. Yeah. Are linear rails worth it? I have excellent result with the wheel and don't like to change things up too much if not needed. Yeah, so we're gonna check that because I have a horrible experience with V wheel, like very bad experience. So the issue I had, and that's happened to a lot of ender, is this system is used also on the z-axis, right? The connection between the gantry and the z-axis. And what happened is every time I was printing, my first few layers were printing pretty much on the same height, and then after one side of the ender was high enough, then the other side would pick up the pace, and then you would go up together. And then I spent a huge amount of time like figuring out what was happening. It was like over extrusion, something wrong with the G code, blah blah, until I finally end up on the Reddit on the subreddit that was talking about this, and then I had to play around with all the wheels, and sometimes they are too tight, sometimes they are not tight enough, and then like for me the wheels are so weak, like they're so flimsy and stuff, and I have a horrible experience with that. So I know it's the system that is used the most because the printer it comes with is the one that sells the most. But definitely, I don't know if I would have had the same problem with maybe some other stuff, because I think the problem was, I don't know if it came from that or it came from the fact that there is no the two z-axis were not connected, which is the modification I made. You need a belt, you need some kind of motion translation between both of them to translate the motion from the actual lead screw to the other one, so that it doesn't translate through the gantry, right? So anyway, I don't know if any of you had that issue, but yeah, I spent like almost a whole night taking it apart, putting back, seeing if it's working, and then doing this, and then trying to print, and then that was a very bad experience. They can be called motion transmission as an engineering way. Yeah, I think he updated it, motion transmission. TL TLDR, too long to read, or something like this. Too long. Linear rails have the same quality as good V wheels, but with a lot less maintenance and allow faster speed. Yeah, and also V wheels are rubbers, right? And rubber will wear out much faster than the other, I guess. The rail used on the V400, though they are not so common. It's all about mass rigidity, and constraint. It's all about mass, okay, the mass that you need to move, or the mass, okay, rigidity, okay, and constraint, okay. Yeah, yeah, that's true. Awesome Zombie. I do find myself adjusting the V wheel frequently, but most due to my OCD and always wanting everything perfect. Finally caught up with the live. Hey, Kevin Tucker. Thank you for being awesome. The only thing worth keeping on V wheels is a Z axis, since it doesn't but need much, but needs to be stiff. Had a massive jam on my primary printer. Good thing I'm printing the same thing 10 times and can move to my CR10. You had a massive jam on your primary printer. Good thing I'm printing the same thing 10 times and can move to my CR30. Rails are better than wheels in terms of maintenance. Yeah, I think so. By the way, let me know if you ever want me to jump on stream with you in VC. Single Z with dual axis, very bad. Yeah, actually, you know what? I think your knowledge about this is incredible. And you know how I know that? Because when someone can organize and structure a topic, it means that in his mind he already have a very good picture. Because if you don't have a good picture of what's happening, there's no way you can organize. So the fact that you organize it so well means I'm pretty sure you have a good understanding of what's happening. So I have two working printers now. So yeah, either it's been a small hour. So either we do it now. I think I can send you a link. Do you want to do now, Zombie? Do you want to come and stream now and give us the pros and cons of the different guiding components? Maybe we can focus on guiding component, and then depending on whether we have time, then we go to the other one. Sure. Okay. So let me figure out how do I invite someone on the stream. So let me move this out of the way, and then invite, copy to the clipboard. Okay, so now, whoops, sorry. Well, wait, I disconnected. Don't switch. Do not enable, and then let me get back here. And then let me send you. Let me send you to Discord. Let me send you to your Discord. Let me send you the link. So that's going to be the first time we invite someone. So I hope it's working. So you can click on the link and see what's happening. I hope I'm going to receive some kind of stuff here. And then let me put you there. Okay, so just waiting for Zombie. Am I going to receive notification there? And yeah, again, if any of you feel that they have, the knowledge that we can share. Okay, there you go. Let me check. If I put you on screen like this, I think. Yeah, can you hear me, Zombie? Hello? I think I can hear you. I can hear the background sound. Hello? I can hear your mouse.
I can't hear you. Hold on.
Okay. Matt German, I have 8 printers working and 2 bad ones. You need more printers. It's Zombie Hedgehog. Yeah, he's coming, fixing some sound issue apparently. Because if he's relying on me talking on the stream, then there's going to be a huge delay in in our discussion. Okay, so he left, and I guess he will join again. Yeah, let's all enjoy Zombie's voice. How about now? Yeah, still not working, Zombie. Is that could it be on my side or?
Is your mic muted in StreamYards?
No, no. Yeah, looks like his voice is too good for the Polymaker live stream. He's not sharing his stream vibe with Polymaker.
Oh, okay, got it. I had the tab muted because I stream on MakerDeck.
Oh, okay. Is that good now?
Yeah, I can hear you.
Okay, great. Is there a lag or can you hear me like now?
No, I can hear you perfect.
Oh, okay, great, awesome. So yeah, thank you so much for joining and then organizing the topic so well. I know you've been printing. Maybe if you don't mind giving a little bit of background so that people understand, why you have all of this knowledge, and then maybe we can get into that.
Yeah, sure. So I am a Zombie Hedgehog. I 3D print. I got into 3D printing just this year, honestly. I picked up a cheap printer and kind of got hooked. I actually got into Polymaker because I needed to get some ABS or ASA specifically. And doing all my research, I ended up with Polymaker because it was the cheapest, well-rated filament that I could find. I didn't actually use it because I didn't have an enclosure, but I bought a ton of ABS for my printer upgrades. And then you made the Discord and I joined, and it's been great ever since.
Cool. When was that, the first 3D printer? When did you get the first 3D printer?
I think March of this year. In
Oh,
less
really?
than 6 months. Yeah.
Well, you're really developing great knowledge in 6 months.
Well, I've been doing this for almost 6 months straight, so.
Awesome. So yeah, maybe you can explain a little bit why you divided into these three main. Is that just because it makes sense, or is that because they are considered as different component? Like, for example, when you build a printer, you have the choice between different guiding component, different motion translation, and different movement system, or
Yeah.
what you are dividing into these three elements.
Exactly. You can interchange any three of them. So you pick one from each section, and that's how you build a printer.
Oh, okay. Yeah, makes a lot of sense. So yeah, how about we dive into the pros and cons then of the one you have listed, and if there is some others that have some additional guiding components, please let us know.
Okay, sure. So I'll start with the motion systems. I just threw this together real quick, so didn't get a ton of stuff in there. So do you want to talk about you said the guiding components?
Yeah, whatever you think
Okay,
makes
yeah.
sense. Yeah.
That's actually what I started with, but it got rearranged. So yeah, there's the main three, as you talked about, V-wheels, linear rails, and linear rods. There are others, but those are the most common. Because you can put together a printer with just about anything that moves. These are the most economical and supported systems. Let's see. So starting with V-wheels. So as I was saying, they're really easy to scale. So the only moving part is the carriage, and the extrusion can be any length. So you can make a printer that's 200 millimeters or 2000 millimeters and use the same components. So it's very cheap to manufacture, and it's a very simple design. Although I don't really think it's that simple. It's actually it's one of the more complex motion systems because there's a
Yeah.
lot involved with it. There's so many variables, and that's one of the reasons why I don't recommend that for beginners. Just because there's a lot of stuff that can go wrong. There's a lot of maintenance you have to do on it, and a lot of people get turned away from 3D printing because of V wheels, whether they know it or not.
So you're talking about scaling. So let me check. If we compare to another one that would be bad at scaling, what would it be?
Let's see. So
So
linear
when you say
rails, for
it's like
example.
length, right?
Yeah, linear rails, the actual rail part, or sorry, the carriage is the same size for everything, but the rail has to be scaled up. And to manufacture a really long and straight rail, it's a lot harder than a smaller
Oh,
rail because they're actually, I believe, they're machining them down,
mm.
so they're not cast; they're machined to precision size.
Oh, I understand. Yeah. So this guiding component has to be is as big as your axis will be, but the V wheel, whatever the size of the axis, the only thing that there's nothing that change,
Yeah,
right? It will always be the same. So that's what you call an easy part to scale because it doesn't scale.
right. And by the way, are you trying to share your screen or?
Oh, yeah. Let me, yeah, there you go. Yeah, so I was just showing the different picture as we were
Yeah, yeah.
talking.
Michael in chat says, "Are linear rails still controlled by a belt?" Yes. So linear rails can be controlled by anything from the motion um, transmission section.
Hmm. Oh yeah,
I,
because the V wheel, there is the belt is there, right? And then
yeah,
so what's moving it? That's part of the motion translation. But the guiding components are only what's connecting from the moving part to the non-moving part, right?
correct.
Okay, okay, okay. And then yeah, anything else on the V wheel? I heard about I know I had issue with what we call an eccentric wheel or something like this. There's one of the wheel that is the hole is not in the middle and you need to tighten it or untighten it depending on something.
Correct. So for any of these guiding or the guiding components, there's a thing called, or at least what I refer to as preload. So that is how stiff the motion is. How stiff the motion is. So when you buy a linear rod or linear rail, they come with a specific preload. So for linear rails, you specify a medium preload, so it's a little bit stiff. Because you can
Mm.
buy linear rails that are really, really loose and they kind of just fall all over the place. But
Mm.
these ones are stiff. For V wheels, they're tensioned by the end user, so the end user has to get them to the proper preload. How they do
Mm.
that? Well, there's all kinds of different ways. You can do it by wiggling the carriage and then tightening it until it stops wiggling, or you can try twisting one of the wheels and kind of feeling how tight it is. You can guess. A lot of people don't even adjust the tension. So,
Mm. So in the case of 3D printing, you were talking about different levels. So in the case of 3D printing, I guess the higher the rigidity, the better, right?
um, to it, there's a range. You don't want it too rigid because it'll be too stiff, and the motor will have a harder time moving it. So, but you don't want it too loose because you'll get printing deformities and stuff like that.
Okay,
So
so
there's
that's
a range. There's a range. It doesn't have to be perfect, but it has to be within that range.
okay, okay, okay. Understood, understood.
Yeah,
Um,
3D HP says snug, but able to spin a wheel barely.
okay, and I guess okay. So on one side, by the way, guys, I'm not looking at the chat too much, but looks like a zombie is better than me on that. even when I don't have a guest, then I have difficulties with the chat. And now that I have a guest, then I completely forget the chat. Okay, I understand. So the rigidity, not too rigid, otherwise the problem comes from the motor. You cannot move it because it's too rigid. And if it wiggles too much, then when it's moving, it's gonna wiggle and have some artifacts on your print. Like for example, not a very good layer to layer consistency. Like okay, I think it's very clear for that one. And so, what would be the reason why this guiding component is the one Ender 3 has used? Is that because it's the cheapest of all of them?
It is. I don't know the pure cost of it, but it's got to be cheaper. It's got to be cheaper.
Okay, okay. And any printer you have in mind that are using this? I mean, except the Ender, or is it really has it come to the market with the Ender? Are they the first one doing introducing?
I'm not sure. Does anyone chat know
Hmm.
if the Ender 3 was, or whatever was the first? This was the only design to copy at the time. Right. So everything was copied off the Ender 3, which is why we call stuff Ender 3 clones. But did anyone do this before? So Open Builds. Open Builds is a community-based printer, though. I'm talking about a company CR10.
Open Builds. I didn't know that. Is that another Voron style? I mean, not Voron style, but custom printer stuff.
I haven't looked much into it, but it's like this custom printer. Open Builds itself right now is just a collection of all these custom printers that people make and design. But there's an Open Build specific motion system that uses slightly smaller V wheels. They do more CNC than printers. Oh, it's a company. Okay, I didn't know that. So they're a company and they use a specific V wheel system.
Okay.
V wheels was designed by Open Builds. Okay.
Oh, interesting. Okay, great. And I think there was a question about how fast do the friction component wear out with the rails. So I guess each of the guiding component will have a wearing issue. So how do they compare with each other?
Okay, so V wheels are probably the worst. I wore mine out in about a week.
A week?
A week. Yep. I had them too tight and they deformed and my print quality suffered. So I had to order new wheels, probably like 2 weeks of printing. And I also, I researched this stuff. This was I had no knowledge of 3D printers, so this was from scratch. But yeah, I had them too tight because people said you just want to get them really tight. So I made them really tight, and then you could move the carriage and it's just lumpy. It feels like lumps.
Okay. And then would the other have similar issue? Because it looks like there's no rubber part on the other. So
the others use I don't know what the rail is. It's probably like a hardened tool steel. So it's a very hard steel rail and a similar steel block. What do they call that? Cartridge. Similar cartridge. And then they use hardened ball bearings. So it's metal on metal on metal.
Okay.
So if they're if they're lubricated properly, then they last a long time, and all you have to do is once in a while relubricate.
Okay. So the maintenance for a V wheel is just to make sure they have the proper tightness, not too tight, not too loose. The maintenance for linear rail is once in a while just lubricate the ball bearing inside, right?
Correct.
Okay. And how about in terms of like you were talking about, you really need the proper rigidity. Is there because the linear rail, you were saying you bought it as it is, right? There's the user cannot change anything, so that means it would be it's actually much easier for people to get linear rail in a way that they won't have to tinker with the tightness, right? Or is there some kind of screw somewhere that would make the ball bearing tighter than other or something like this?
Nope, it's completely manufactured. Does anyone in chat know what makes the preload, the stiffness, the preload? Like, how do you define that? Actually, is LDO still here? They would know.
Yeah, maybe.
Because there's the rail size, which I think is consistent, and then there's the ball bearing size, and then there's the carriage size. So there's those three components, and then the combination of sizes of them would define the preload of the tension.
Okay, would it be? Do you think it could come from the accuracy? Like if you want something very rigid and everything has to perfectly fit together, so maybe are they more expensive? Are the more rigid linear rails more expensive than the loose one?
I don't think so, because they're the same thing. They're just different sizes.
Oh, okay. So maybe that doesn't come from that, because in my mind it was like a rigid one would be like super precise, and then it doesn't wiggle at all, and then the cheap one kind of wiggle. So, but okay, that doesn't have to do with that. FDAF patch preload comes from the machining tolerances. Lower tolerances give you bigger and higher preload. Yeah, that's what I was thinking. But then that would make the part more expensive. That would make the more rigid part more expensive, I guess. Preload is the tolerance between the rail and the inner top face of the carriage. Yeah. Cool. Do you have wait, actually there's a third one. What is this one? Linear rod.
Yeah, so that's like what a Prusa uses. I believe that's technical term, linear rod, but it's a very similar concept. There's a bearing, but the balls go all the way around it, kind of like in a cylindrical zigzag. Maybe we can pull up a picture of a linear bearing. But they ride around a rod, so the rod itself is only supported on 2 points. It's only supported at the both ends. Yeah, so that's the. Should I look at the live one? Yeah, that's a cutout of it. So there's. Okay, this one has the balls just going back and forth. So it's just like a linear rail, except it has 4 sets of balls, usually 4 sets of balls that make contact with the rod.
Oh, okay. So now the question would be, because it seems to be the same idea, linear rails or linear rods bearing, and but one is a cylinder shape and the other one is a rectangular shape. Is that the only difference, or?
And how the rails mount, and I believe linear rails are more stiff, not more stiff, more have more constraint, so they don't jiggle as much. I believe.
Oh, then okay. FDAF patch, the machine a lot of rails and cartridges, then they test the tolerance and match them accordingly to their tolerances and space between rail, ball, cartridge. Lower space gets a bigger preload. Okay,
so they don't actually manufacture it for it. They just spec out their rails as different preloads.
Seems like so. Yeah, seems like so.
Okay.
Which would make the price the same. Now it explains why they are the same price.
It's kind of like how they make processors, CPUs. They just make them, and then they test them, and the good ones become high quality processors, and the bad ones get partially disabled and sold as cheaper. But they're all the same thing.
Oh, really? I didn't know that.
Yep.
Interesting.
That's why all the expensive ones come out first.
Yeah, well, it's the same in polymers, actually. There's some polymers that are really expensive and some polymers that are cheaper, but they're actually the same. But it's just that the one that is very expensive has came from the production with higher specs, or like they were better within the range, within the molecular weight, for example,
Yep.
and then the rest is sold a bit cheaper. That's interesting.
Yep.
Um, okay, so now a quick question. I've seen these guiding component. Would there be any one that would be preferred for any axis? Like one is more for the z-axis, one is more for the xy axis for this or this reason, or all of these guiding component can be used in all of the three axes?
Yeah, they're interchangeable. They all do the same thing. They're just integrated differently.
Okay. So there wouldn't be any, for example, if you need, yeah, here's a question. If you need speed, let's say, um, oh, wait. First, the price difference. Are they similar prices, or is there one more cost effective than the other one? Like
So
I get the V
as
wheel.
FT Patch says in chat, V wheels use the frame as a guiding component, so it's cheaper. So that's why it's cheap, is because they just take the frame and they add these cheap wheels to them.
Oh,
Yeah.
yeah. That's a good point. Okay.
But
Yeah,
then
because,
linear rails and linear rods are actually about the same price.
oh, okay. Yeah, because for linear stuff, then you need to add one more component that will guide the rail, right? So that, yeah, okay,
Yeah.
I understand.
So for the z-axis, if you're using a lead screw, you only need one linear rod, because you, in general, if you're using a linear rod, you need two of them, because it'll rotate around itself. So you need a set of rods. That picture is weird. I actually have no idea what that is. It has like a linear rail and a linear rod. I realized that
Oh,
after
yeah.
I posted it.
Yeah, what you're saying is the lead screw will act as the rod, and then you just need one other on the other side, right?
Correct. So that
Uh,
might be a cheaper option for the Z, but then on the X, you would need two of them. And as someone said in chat, who said that? Linear rails are stiffer because they're supported from many points on all the holes. Linear rods cannot be supported in the middle, so it has a maximum distance. So as it gets longer and longer, it's more flexible.
Sorry, can you repeat that? Why the
Yeah. So linear rods are
uh-huh.
only connected at 2 points. The whole intersection is open. It's floating,
Oh,
unsupported.
okay. Oh, okay. Yeah, I get it.
Yep.
And the
And you
linear
need,
rail, yeah. Okay.
yeah, linear rail is screwed onto something. It's screwed onto an extrusion, or usually an extrusion. So that helps add to the stiffness.
Okay. Yeah. Makes sense. So that goes back to scalability as well. Big printers, I guess, how do you call that again? The linear rods would be a very bad idea, right? Because it would completely bend if it's too long, right?
Yes. Yeah.
Okay.
Yeah.
Got it. And yeah, you were talking about you need a set of rods. For example, I'm trying to understand what is in the middle here. Is that a mix between a linear rail and a linear road?
Yeah. I don't know why I posted that picture. It's really weird. Can someone find that for me and figure out what that is?
It's
Do some
orange.
homework.
I thought it was. I thought it was a Prusa. I guess not.
I don't know. It's definitely not a Prusa. Linear rails, or the shape of linear rails, help make them more rigid. Yes, that's
Oh, it
true.
is. It is a Prusa. I mean, at least
Oh yeah.
here
Someone
they
must have
use.
taken a Prusa and then
Yeah,
added a linear rail because stuff mounts to rails better. Or I don't know. Oh, Prusa linear rail mod. Okay.
linear rails has become cheaper because the popularity from the 3D printers, and linear roads are getting expensive because they are getting forgotten on the 3D printing. Yeah, offer and demand, right? Interesting. So, okay, is there some other fancy one guiding components that you didn't put because they are not common, but
There's one more. What's that printer called? The Pantheon.
yeah.
It uses all ball screws for everything. So I do have that in the other section, but it's not common at all. You might want to type printer.
Yeah, yeah.
There we go.
Oh, yeah. Okay, they are using. Oh, okay, okay. So they. Whoa. But does that is that fast?
Yes.
But
Yeah.
you need crazy stepper motors, right? I mean, you cannot do that with the regular one, no?
Oh, did anyone find that GIF of Nero, or could you post that somewhere? You know the one I'm talking about, right? In chat.
No. What?
Oh yeah, I got it. No, I don't got it. Nero on stream, he has a ball, or a linear. Sorry, what is it called? A ball screw,
Uh-huh.
and he shows how fast it moves, but it looks a bit explicit, so he took it down.
Oh, okay. Yeah, it looks like the motors are completely different. I mean, these are massive.
These are servos, so they're
Oh, okay,
closed
okay.
loop stepper motors,
Yeah, yeah, yeah.
which is something I might look into for one of my printers.
Nice, interesting. So, okay, V wheels, linear road, and linear rails. Um, yeah,
And they
no
posted the link
scanning.
to in chat. Yeah, they posted a link down there.
And that's for the linear rail. Oh, so that's the upgrade. Let me open that on the other screen. Let's check that. Oh, okay, okay. So there you go. This is where you got the picture.
Interesting.
Oh, so
So
they
that
mix.
that must help with stiffness, I'm guessing, because a rail in general is more stiff than a rod. There's just more mass,
Okay,
so
interesting.
that probably adds to the stiffness.
Hmm.
I
That's a
highly
drive system.
I highly doubt that affects it too much for that size, but it's probably something.
Okay. And yeah,
Later.
sorry you
Oh
answered that already, but
no, don't delete that. Don't delete anything in the Discord. This is when I post like something like this. Anyone's free to add to it.
hmm.
The whole point of this stuff is to archive all the information.
Yeah, yeah. And yeah, for speed, which one would you recommend for speed?
Definitely linear rails. That's the
Okay.
rods are they're too flexible. They don't have they're not rigid enough for high speed because
Okay.
they're unsupported.
Okay. Nice. Yeah, I think that gives a really clear
Yeah.
pictures. I don't have specific other question. I
Does
usually have a
anyone
lot.
in chat have any questions about that? Did I make that clear enough?
Yeah. So yeah, if no one in chat has picture questions, then we'll go to the second element. Um, cross cross gantry. Oh, the hang printer. Yeah, yeah. I've seen that printer actually during TCT show in Shanghai. It's a very interesting one, but I guess yeah, it's very particular. I put a linear rail y-axis mod on my Prusa. It doesn't allow me to print faster, but it is definitely more rigid and quieter. Oh yeah, that's a good point. Is there is this something to do with noise? When you choose these, are some more noisy than other, or yeah, it's the same.
I'm guessing the rods have more balls, so they're louder.
Oh,
The more balls you have, the louder it is because V wheels are actually really nice if you want a quiet printer because it's a silent motion system.
mm,
Because you can listen to the balls go on a rail.
mm. Okay.
So I think that probably
Uh,
sums it up pretty good.
mm. Did you explain cross gantry? Kenneth Song, I have no idea what is cross gantry, so I don't know if it's part of this element. What is? Do you know what is that? Zombie?
Yeah, yeah, it's part of the third discussion.
Oh, okay. So
Essentially, it's core XY, but or it's core XY, but instead of just having one rail go across, it has two rails going across and a cross gantry. The annex systems use that. It's a lot of linear rails, I'll tell you that.
okay.
It uses six linear rails just for the motion system.
You know what's funny is we just said that V wheels were the best to scale up, but every time I see linear rails is for large printer. Every time I see V wheel is for tiny printers.
Okay, V wheel is not good for in terms of performance for scaling. They're just good in terms of cheapness.
Yeah, okay.
That's why manufacturers use V wheels for like 500 millimeter printers, because the cost of a 500 millimeter rail is significantly more than V wheels.
Okay. Cool. Actually, probably had more to do with lubrication, but my experience has been that they are slightly quieter. Okay, Caleb. Yeah, that's good to know. Didn't understood anything. Can you repeat? Okay, so maybe we switch to the next one, which is motion translation. So that's about how the printer can take advantage of the stepper motors, right? Going from spinning to translating. So if I understood properly.
Yep.
Okay, and you have belts, timing belts, ball screw, and you added a picture, but I don't know if it's ball screw can replace in your rev, blah, blah, blah. Okay. So you only have two, right? Is that correct?
Three.
What's the last one?
Ball screws. So there's belts, lead screws, and ball screws.
Oh, lead screw. Oh, it's different. Okay.
Yeah.
Okay. So yeah, let's go then. What's what's the differences?
Okay, so everyone probably has belts on their printer. Almost every printer design uses belts on at least the X and Y axis because they're the best for speed and cheap. They work very well for being cheap.
Okay.
I guess I can explain how they work a bit. I think I wrote that down. So it's a motion path that can go in multiple directions and support fast movement. So unlike any other motion system you might find, belts can change direction. So think about like a Core XY or any other printer like that. Hold on. 3DHP says, since you're on live, let Nick know his countdown 5, 4, 3, 2, 1. He says that out of order. I'll let him know. Anyway, so yeah, that's the main advantage of belts is it's very versatile. It can be used in any design. It's very simple. All you have is a motor with a pulley, and then at least one bearing. That's all there is.
Yeah. Okay.
So it's very simple, and it scales very, very well. Very well.
Last time we talked about issue with tension. So is that one of the downside of belts? Like, what would be the downside?
Yeah, tensioning is definitely a big factor with belts. They need to be within a certain range, just like the tensioning of V wheels or anything in the printer. So if they're too loose, then you'll get banding. So they'll stretch as you print. So as you accelerate, they lag. If they're too tight, then the motor will struggle to keep up and you'll wear out the belts. But if they're just right, then it's perfect. But how do you know how tight that is?
Yeah.
That's the issue.
So is that the same issue with the ball screw? Are you going through timing belt every 1 or 2 weeks?
With ball screw,
Sorry, with the V wheel.
with V wheel, yes, yeah. If you over tighten V wheels, you will just wear them out.
And is that the same thing with the belt? Like, are you changing it? Because you said you change your V wheels almost every 2 weeks, right? Is that the
Well,
same belt?
if you have them way too tight, with the
Oh,
belts, no, those last a lot longer,
okay.
especially
F,
the good belts.
uh, belts are stretchy, bouncy, and easily oscillate. That's the issue. Okay, yeah, I guess that's the so the pros, they're cheap and they're scalable, and the downside is they are yeah, stretchy, bouncy, and easily oscillate. I guess
Yeah,
does that summarize it properly?
yeah, just about. Especially with cheap belts, and people are saying in chat V wheels about every 2 years. Yeah, about it depends on how much you value your print quality. They will wear down quicker than that. If they're
Hmm.
perfectly tensioned, you'll probably get over a year with your V wheels. And it also depends how much you're printing. There's no time span. It's hours printed, really.
Mm-hmm. Caleb is saying they shouldn't stretch much if you get good belts. So that brings the question: what's the difference between the different timing belts? Do you have good quality one, bad quality one? I guess is that the material they are using, the elastomer they are using, or is that the wires that are inside that are changing? Or
It depends how they're made. Some of them are reinforced with different materials. Some
Mhm.
of them are uh, better than others. Let's see what I have over here. But yeah, you can get cheap quality belts, just like I guess like regular timing belts, and those won't work as good as like a Gates belt.
Sorry, Mark and Draka also talked about Gates belts. What's that?
I can show you. So Gates, can someone explain that in chat? It's just a manufacturer, right? And the GT2 belt is a standard size.
GT2. Yeah, sorry, we are going into vocabulary I don't understand.
Yeah, no worries. There's a lot of vocabulary for that.
There's V belt. Oh yeah, V belt because of the shape. Okay, but gate. Okay, this is a gate belt apparently. Gate. Gate.
GT2 is a teeth pattern. Okay, I didn't know that.
GT2. Yeah. So is there a difference between timing belt and gate belt, or is that the same?
Um, I think they're all called timing belts. I think that's the style.
So timing belt is like all everything, and then within timing belt you have gate belt that are some kind of.
Gates is a manufacturer.
Oh, Gates is a manufacturer. Okay, sorry. Oh,
I
okay, okay.
think. Yeah, manufacturer. I'm
Look,
personally still learning a lot, so
you what? Sorry.
I'm learning a lot as I go.
Yeah, same here. Well, GT2 is a car.
Oh yeah, there you go.
GT2 belt.
They probably use this timing belt in the car.
Yeah. GT2 GT2 timing belt. Okay.
Yeah, so that's the specification for the little notches in them. So you
Okay.
have the
The
that's the
pitch is 2
pitch.
millimeter. Okay, got it.
Yeah.
And nylon covered, fiberglass reinforced, neoprene, breaking strands, blah, 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 natural percent, blah, blah. Oh, okay. Oh, temperature range. Oh, it can go up to 85 degrees C. I thought some people didn't use enclosure or heated chamber because of the belt, but 85 degrees C is not bad, no?
I think it depends what belt you use.
Like this GT2 apparently. GT2/6 means 2 millimeter pitch and 6 millimeter wide belt. Okay, got it. Gates does make timing belt for Auto 2. Okay, got it. Okay, so Gates is a company. Okay, got it. Gates makes a lot of timing belts, and they are known for producing very high quality belts. Oh, okay, okay. Is that a? Oh, I think Zombie just disconnected. Yeah, maybe something wrong on his side. Um, you can get high temperature belt that can withstand over 100 degrees C. Let me check. Let me put you back in the. Yeah, there you go. You still hear me?
I can hear you.
Okay, great.
I hear myself now. Okay, that's better. So yes, this is actually the belt from a Voron. It's a Gates Power Grip. So looks like that.
How do you call that? Power grip?
That's the model. Yeah, that's the model Power Grip. So that's a typical one you see on printers, and some of them actually come with Gates belts. My BQ came with one, I think.
Oh, okay. So Power Grip is a model, is a product model, right?
Yeah.
And Getz is the manufacturer of Power Grip. Okay, got it, got it. Yeah, yes. Even in just the belt itself, there's a lot of stuff. So here's the question. I guess there is a standard for the pitch for all 3D printer, right? Is that everything is 2 millimeter, or do you have some printers that are using different pitch?
As far as I know, all 3D printers use that same pitch.
Okay.
Just different thickness of belts. So 6, 9, 10.
Okay, okay. And then different material and different reinforcement, right? But the pitch is always the same.
Yep.
Okay, understood. Understood.
And by the way, my workspace is not very clean. I just I pulled the Nick method of just sliding everything out of the way. Trust me.
Generating gates. I have an Ender 3 come with gates, but not necessarily the high temperature one. Voron, use whatever belt you choose. Gates is strongly recommended though. Okay, so in the Voron community, they recommend Gates Power Grip, I guess. Linear rails with heated chamber. Yeah, go ahead.
There's no real other options that I know of, so this is kind of what they use.
Nathan, steel core belts require large bend radius, and the pulley on 3D printer are too small and will destroy the belt. Oh, yeah. I guess depending on the reinforcement, you can more or less have a very sharp belt deformation, right?
Okay, yep, that makes sense.
Got it. Are they reinforced? The one that you usually use, like the Power Grip you have on the.
Yeah, feels pretty reinforced to me.
Okay, interesting.
Yeah, they're good, but I don't want to get too much on belts. Essentially, everyone uses either the Gates belts or other cheap ones.
Okay.
And belts are important because I think they're used on like every single printer. I don't know of any printer besides the Pantheon, which uses ball screws, that don't use a belt.
Yeah. And for the belts, so just to clarify, so Gates is to belt, was LDO is to stepper motors, right? Kind of.
Yes, exactly. So just the high quality manufacturer, and then there's the other knockoffs.
Okay. Gates is the company. GT, it's the profile of the tooth. The number 2 is the distance between the tooth. The Power Grip is the technology of reinforcing and finish on the teeth. Oh, amazing. Okay, great summary. Thank you, Daft Patch. That's perfect. Yeah, I think that's very clear. Maybe my last question for the belt is, can this motion translation system be used for any axis, or are there some axes preferred?
Okay, so they're used for X and Y because of speed. They're very, they can be used very fast, But the next thing, which I'll jump right into, if I can pull it up, is the lead screws. So lead screws are typically used on the Z axis because how they work is you have a stepper motor with a lead screw, which is like a really long bolt, a really long smooth bolt, and then there's the nut on it with holes in it, and the actual transmission ratio between the rod and the bolt, or the lead screw and the bolt, is very very high. So it takes a lot of rotation to get a little bit of movement. So that's preferred for the Z-axis because you're not moving very much at a time, 0.1 millimeter, etc. So you need that accuracy. So that's what's used for the Z.
Okay. Maybe something to clarify here. It looks like lead screw is another. Oh no, you're translating. So let me check. So does that mean you need to buy a specific stepper motors that has this thing in like embedded inside?
You can. LGO has some nice integrated, they call them integrated lead screw steppers. They're generally a lot more straight with like less wobble or something. Just higher tolerance.
Okay. And
also, lead screws have a higher load bearing capacity because they're really high geared, so they can take more weight and move more weight.
Yeah, makes sense. Okay.
Yeah.
And sorry, what does lead mean? Like, which part is a lead meaning?
I don't know. Probably it leads the motion. Does
Oh,
anyone
lead,
chat know what lead means?
lead screw. Okay. And okay, so in that thing there is some ball bearing. Okay, so it's following the threads. The ball bearings are within the thread. Okay, interesting.
That's a ball screw.
Oh, that's a ball screw. Okay, sorry.
Yeah. But I'll
So
get to that in a minute.
what's inside the lead screw? It's nothing, just two threaded component, and they just spin accordingly.
Yep. Do I actually?
So does that mean you have to lubricate this a lot?
Yes.
This.
You need a heavy amount of lubrication on that, but a different type. So this uses a PTFE lined lubricant, or a silicone. Not as silicone. What's the other type? White lithium, I think you can use, but some type of grease, some type of non. What does my bottle say? Something that doesn't attract like dirt.
Okay.
So it'll last for a while. You can't lose super lube on. Actually, can you use super lube? I don't think you can use super lube on those. But regardless, they need to be lubricated, yes, because the biggest issue with these is you have a solid steel rod with a brass bearing. So the nut, and the nut is designed to wear down before the. Oh, there's a good picture, a couple good pictures. But the brass wears down, and it wears down pretty quick because you have brass on steel, probably steel, aluminum. What are these things made out of? But brass is the weaker material. So over time, you need to replace these because they'll loosen up.
Okay. And I've seen some modification on printers where there is part like so one side is on the stepper motor and the other side is not supported. And I've seen some modification where you support that side. Is that to make it more straight, right?
I'll be honest. I've heard a lot of mixed topics on that, which that'd be great to discuss on PRINTBUSTERS if we ever do that. But if you constrain it, then if the rod has any wiggle in it, as it goes around during its rotation, it's not going to be a consistent rotation. So it's going to have more force as it goes around. because
Oh,
it's moving. So I have no idea why that's a thing. It doesn't make sense to me, because if you constrain it, then you're going to have more issues than if it's unconstrained.
oh yeah, that's a good point, because there's already two parts, right? There's the stepper motor plus the brass part that is connected to in this case the linear rail. So you already have two parts that is maintaining it. So what you're saying is if you add a third one, then that's mess up, because now you have 3 point on the line, and 3 point on the line. You have to have the 3 point aligned.
Right.
But 2 point is much. Oh yeah, that makes sense. How about I don't know if there's anyone in the chat that has this type of printer, but what's your thinking of this? Do you need to put that modification on top where you need to maintain the tip of the lead screw, or do you think it has to be let loose? F patch lead screw is called lead because lead it's the property of how much strength or movement you have by one rotation. The correct engineering term is power screw. Oh, okay. Yeah, here's some good definition there. FDF patch, you're very good at making a great definition. You need to get Nero in to talk about lubrication. Why? It's also lead screw have backlash more easily and more friction. What does backlash mean? It means when you're loading on one side on the other, it's going to wiggle. Is that what backlash means?
Yeah, backlash is. I actually have some. Oh, there we go. I have some anti-backlash right here. Yes, backlash is when since there's play in the system, the backlash happens when you move up, and then it keeps going because there's motion.
Mm-hmm.
It can't stop on a dime. So because there's play, there's gonna have backlash. So if you have your like acceleration on your z-axis too high, then you'll have backlash. Let me see if I can put this together. I should put my zoom camera in.
Do you have a hardware warehouse or what?
Yes, I do. I'm not joking. I can build like a lot of printers.
Backlash is jeu fonctionnel. Okay, yeah. I guess so. I guessed so. Non-fun. Backlash is when there is play in the motion. Yeah. Okay, got it. Lead screw should be kept floating. I believe constraining both ends will result in print artifacts. Okay, Caleb, that's a good print buster topic, because I've seen a lot of people making that modification. So if we could, bring some science there, and then explain that it might not be a good idea, then that would be great. I think we're bringing something there.
There we go.
This screw should be kept floating. I would keep one end free. Okay, so most of you are more on the side that we should not do this modification. That's good to know.
Yeah.
Non-fun. So the screw is steel and the nut is brass. Okay.
Yeah. So here we go. So this is a lead screw. I probably focus again.
How do I put a certain?
I gotta manually focus it, so bear with me. Good enough. So yeah, this is the brass nut. Where am I? Right here. That's the brass nut, and that just slides along. It's pretty smooth. And it'll actually go by itself. There we go. It'll go by itself if you twist it. But the issue is there's play. So I can move this back and forth, and there's a little bit of play in it. It's not stiff. So like you want in a linear rail, this thing right here is stiff. There's absolutely no deformation in the other axis. it only goes in the one direction.
Does that really matter in a way that there is, if it's used on the z-axis, then there will always be the load from the gantry, right? So that means, does the play matters? Because there will always be the load of the gantry.
That's a good question. It depends.
Because if you're using on the XY, then I would understand, because if you spin on one side, then it would be on one side, and then you start to spin on the other side, and then you will have that play that will be a little bit late. But if it's on the z-axis, then it will always be on one side.
Yeah, it's not a huge issue, but it can cause problems, and people have seen issues with it in the past. But
okay. Interesting.
For example, I just installed an anti-backlash nut on it, so that has a second free nut on it, and it connects to the main one with a spring. They're also, yeah, Mark, does it look like this? So that helps with anti-backlash, because now if I move this, there's tension on it, actual tension.
Oh, can you still hear me?
Actually, I can only hear you when your screen is like that.
Oh yeah, because I was trying to play around. Oh, so that means I was talking earlier, but
Oh, sorry.
yeah. Let me just. So I was asking, does that mean it's harder to spin because you're putting tension now on the nut?
Well, the second part also connects to it with like a little coupler. So, and then the spring just helps it a little bit.
Okay.
So let me see. I have the spring in there. It's not very visible.
Mm-hmm. Okay, and then the next one, which looks very similar to me, is the same thing, but it's called a ball screw, right?
Yeah. It's completely different.
Okay.
So the only thing the same is that it's a rod, and it has something that rides along it. But the rod
Which
itself, the rod itself has a different bore to it, so it has rounded out grooves instead of the hard square ones like these have. And the actual, is it called a carriage? I don't know what it's called, but the nut part has a bunch of ball bearings in it, and the ball bearings ride along the track. So instead of having metal to metal contact like these, you have the same smooth ball bearing contact.
Which is metal to metal, right?
Yeah, and if you want to share your screen, you could probably.
Yeah, I'm checking the ball screw at the same time. Let me put that back. Okay, so I do understand. So I understand the difference of the nut. Like the difference is one nut doesn't have the ball bearing and the other has. But I do understand you said the screw is also different.
And very. Yeah. So click on that picture. That's a good one.
This one, the second one.
Yeah. So it has a continuous chain of balls, like a standard linear rail cartridge, but it's just in a circular motion.
Okay, but the screw itself, why the screw is different?
So look at the pitch on the actual threads. They're at like an angle. So there's a groove for it to ride in. On typical linear rods, they're just like sharp. They're squares. If you can find a profile of it.
Oh, okay.
So it's like an extruded square versus a triangle.
Okay. Oh, okay, okay. So like the it feels smoother, right? The ball screw.
Yes.
Oh,
Yeah,
okay,
it's
okay,
rounded. It's like rounded because there's balls riding inside of the track.
okay. Yeah,
And
in my mind, it's like this picture. They are they are the same, but one has balls, but the other one doesn't. But there is
uh,
some stuff to it. But yeah, I understand because.
essentially,
Mm-mm.
profiles of shape. Okay, so not pitch is how far the thread is. Profile the shape of the thread.
Okay, okay. So in the ball screw, the pitch is most likely the same, but the profile is different. Okay, got it.
Correct. Ball screws look like linear rods and lead screw combo. Yeah, that's exactly what they are. It's a
Oh,
it's
yeah,
a
yeah,
linear rail, but on a rod.
yeah, yeah,
Or no, linear rod.
yeah.
Um, my linear rods are in a printer, so I can't show them.
Yeah, yeah, right, okay. So how? Yeah, well, it helps with what to have this. Is that just smoother? You don't have to lubricate compared to the other. Like, what's the advantage?
Well, it's stiff. It's like they're ball bearings, so there's no play in the system.
Oh,
So it's extremely stiff, and it has the same properties as other ball bearings, so it can go very fast. Ball screws have zero backlash; they're more precise. Yep,
mm,
which is why the Pantheon uses all ball screws, so they don't use any belts. They don't use anything else. They have a stepper motor tied directly to a ball screw, and that is their only motion.
mm.
I think.
See you, Arturo. Thank you for joining the stream. Um, okay, okay, okay. Got it, got it, got it. So does that mean it seems to be much more expensive? Like when I see the system,
You
yes.
don't want to know how much these cost.
No, like one. How much does one cost?
Yeah, so if linear rails are in the order of like $20 to $30, these are like $300 to $1,000.
Oh, really?
They're expensive. Yep.
Okay, okay.
There's a whole thing on different grades and quality. In fact, I know someone good to ask. Mirage C has a whole video on that because the Hevort printer uses ball screws
Uh huh.
on the Z axis. So
One ball screw,
he has
one
a whole
printer.
series or video on a modification that they do to those to make the cheaper ones more stiff.
Mm.
Yeah, one ball screw costs one printer. Yeah, there
Yeah,
you
if
go.
it's 300, then yeah.
Yeah,
I didn't know it was that
yeah.
expensive. Okay,
For the
but
good
that
ones. Now
the
you can
good
get
one.
the cheap ones aren't that bad. They're about the same price as a um a linear rail, but the
Mm.
quality is a lot different.
Oh, okay. Yeah, that's pretty
Oh, there we
satisfying.
go. Cameron says rolled ball screws and ground ball screws have a big price difference. Exactly. So there's two different ways of manufacturing them. One of them is kind of extruding them as they go, and the other one is actually milling them down in a machine.
Uh, Come again?
Um, I'm not very knowledgeable in this, but rolled ball screws are um, kind of, I think they're like extruded as they go or
Okay.
something, and then the ground actually take a precision robot and grind them down to a precise size, which is why they're way more expensive.
Okay. Ground ball.
Did I get that
Oh,
right? I don't know, probably. Honestly, I'm gonna link the video for that because that's a much better explanation.
okay. Yeah. Cool. Cool. Okay, and then so same question as the belt. So for the belt, you said belt is good for the speed. So that's why it's mainly used for the X and Y. Do I know any printer that is? Do you know any printer that is using belt for the Z axis? I think there's one of the loose bot that that is using belt. Or do you know any?
um, like a printer you can buy.
Yeah.
I Not that I know of. Does anyone know?
I think there is a loose spot. Z-axis belt. I think there is. Um,
I can show you a printer that has a belted Z.
would there be any advantage of having a belt for the Z-axis? Because it doesn't seem very. Oh,
Yeah,
this
so
is. Oh yeah.
yeah,
Okay.
so it gets rid of all of the issues with the lead screw, because it's belts are a stiff system, so there's no play in the belt. So whatever movement happens on the Z is translated 100%, whereas you have the issues with the backlash and general. If it's not lubricated, then you'll get, what's the term for that? When they binding, you'll get binding on lead screws. It's very common when they're not lubricated. Z wobble. So if you don't have a straight rod, then it'll fix that issue.
Mm-hmm. What's Z bending? Is that the wobble also, or? Oh
Yeah,
no,
just
bending is the
when it
fact that it's not straight, right?
yeah, when it's not straight and other issues and binding and
Caleb, it gets rid of lead screw issues at the expense of complexity. Okay, so installing belt is more complex than having a simple lead screw.
it is, because you can't, well, depending on how much weight you have and your system, you can't have a motor tied directly to the output. You have to have a gear reduction, like we were talking about with the lead screws. Is it's very high torque, so it takes a lot of force and it can hold a lot of force. But if you just have a belt hooked up to the end of a motor, you're relying on the motor's holding torque or in general torque.
Yeah. Mm.
So I'll actually show that. I don't know how to set this up, but oh, there we go. Perfect. Poor printer.
Because yeah, if your gantry is very heavy, then the belt, yeah, will heavily rely on the stepper motor, right?
Yeah. Yeah. So this is a traditional Voron 20 tooth to 80 tooth transmission.
Mm-hmm.
And that's used on the Z-axis to increase the torque of a motor. And it gives you more precise movement because it's like a 1:5 ratio or something.
1 to 5. Shouldn't it be 5 to 1
5 to
to be
1.
more accurate?
5 to, yeah, whatever the.
Yeah. Okay. Okay. Yeah. Yeah. Okay. Okay. I've seen in Joel's video the Murph 60 second. I think one of the presentation he was talking about using a special way to use the brake of the stepper motor in order to use the belt on the Z-axis. So that's what you're talking about, right?
Yeah, exactly. Well, yes, yeah,
Kind of. Okay.
yeah. I'd have to think about that a bit. I forget what it actually does. But when the coils are energized, there's a magnetic field.
Uh-huh.
But what does the brake do? Does it just? I'd have to look into that.
Yeah.
Motors have always been my weak suit in the electrical engineering. So
Michael Zombie, do you build printers completely from scratch?
I am currently building what's called the Simple Core printer. That's a from scratch printer. Yes.
Cool. Cool.
But I buy a lot of cheap printers on eBay and fix them up, and just for fun. I buy like at least like have one of everything. So I have an i3, I have a bed slinger, I even have a resin printer now. I just want to get like all the knowledge I can so I can help other people easily.
Nice. That's pretty cool. Pretty cool. And then maybe are you going to build an extrusion system like what's his name again? Mirage C? Like that's very cool to learn more about materials.
I was thinking about it. I don't use plastic bottles, so I don't have any plastic. So, but that could be a fun project to do. I have so many other projects planned that it's
Nice.
it's hard to know pick what I'm doing.
Including building a positron, right?
Yeah, when that comes out, I want to build that. That looks like fun.
Cool. Cool. Bildesma, what was the question about motors? The question was during Joel's video for the 60-second Murph. There is one of the presentation that was talking about using belt for the Z-axis, and he was referring to being able to do that because he was able to use the braking property of the stepper motors or something like this. So we are trying to remember what it was about. Because I guess there is some issue of using belt on the Z-axis, which is when you're not using the motor, then the gantry is basically falling down. So there must be actually your printer. If it's shut down, then what is happening?
Which one?
The printer that is there that is relying on the belt for the Z-axis. If it's shut down, then is that falling?
Yes. Yeah.
Okay. So
it'll lose its position easy. It because of the transmission ratio here, it helps out quite a bit. It's actually required to have this. Otherwise, there's just way too much weight on the stepper. You'd have to have a really big stepper in order to overcome the resistance of that. But this uses, if you do a belted Z with two independent motors, you need to have each one on its own driver so you can level it.
Okay.
A lot of people, and this is something I didn't realize, and it's on topic. If you have a dual Z, like a Ender 3, and they're using the same stepper motor, and you turn off the printer and you like adjust the gantry and you like push it a little bit, they'll go out of sync.
Yeah.
I found that out because I had to relevel my bed almost every time I turned off the printer.
Oh.
So
there is this thing that SWN as is sharing. So do you have a belt Z axis but don't have room or the desire to do gear reduction system to keep it from falling or pour off?
So what does
with
do?
this board, turn your motor into a brake. No need for firmware changes. That just plug in line to your motor and to a 24 power source, and you're ready to go. You can wire directly 24-volt power supply to watch for voltage drop, blah, blah, blah. Okay, interesting. So that's what he was talking about.
Yeah. So this is an active brake, so it needs power to run. What it does is it locks the magnetic field in place. So it applies current in a way that the.
Okay, so if you shut down the printer, then it doesn't help, right?
I believe so.
Rather than the gear reduction does help a little bit, I guess.
Yeah.
Okay.
I think that's the case. Correct me if I'm wrong. Oh, and yes, I'll note. By the way, this is not a Core X XZ. This is just a belted Z. This I linked it in chat. It's the Kevin aka Sam belted Z mod for the Ender. But the switch wire uses one of those like little badge retraction things that you put on your belt. So it uses that system, the keyback system.
The what? The key what? Sorry?
Key what's it called? Key something. Someone in chat would know. But it uses a second spring to help tension the Z.
Okay. Znaz, from what I understand, it's specifically meant to be used when the printer is off. Okay. Well, if it needs, use I/O port on your board to be complete control of it. Yeah, if it's need to be plugged in, then it seems that if it's off, then it's off. It doesn't work anymore.
Pairs and separate to lock it in place.
It's probably the short.
So if you short a motor, so I want to do this live. How does this work?
Oh, you have that. That thing, the Project Red.
No, but I can short out the coils in a stepper.
Oh, uh, about how much do you think a belted Z drive mod would cost in total for Ender 3?
40
Um,
$40.
$40. Okay.
Yeah.
Then you probably just short the coils. Okay. Gear ejection, just use the friction in the system to hold it in place. Yeah, yeah. Yeah, that's why I was saying even if it's off, then gear reduction would help. Keyback, retractable badges. Okay. Keyback. Don't short them to each other. Short each coil independently.
Okay.
Um, how would that work? Stepper motor, supermotor, schematic.
I have some stepper motor cables.
I can hear all the. It
Oh,
looks really like you have a warehouse.
I do. I gotta see which aisle it's in.
This. This.
I
Okay,
don't want to
so
have to crimp a cable to test that.
let me put like this. Okay, so the idea is to shortcut what was I saying? Hey, good morning, Jerry. Um, Keyback is like a pro version of the
One
retractable
moment.
chains that you see all the fictional security guards have. Oh, I know what you mean. But we wanted to see blue magic smoke come out of the stepper. Yeah, hopefully nothing's gonna catch fire on Zombie's desk. Um, yeah, Zombie is on the stream as well. He's trying to help us understand more about hardware, and he's about to make an electro boom experiment.
Yeah, right. Let's see.
The Z brake board physically short the curl independently. Yeah. So what I'm trying to understand here, what does shorting the coil mean? So that's why I put a schematic on screen in order to to understand what shorting the coil mean. Like I understand that the coil are they're circuit differently, and then you have all the different switches. And I guess when you're making the motor spin, you're basically playing with all of these switch on, switch off, switch on, switch off, and that's what make it spin. So I don't understand why if you shorten them with whatever it means, then it's gonna stop it from spinning. So yeah, that's the thing.
Okay, so I have a LDO motor. I like that in chat. It has the PDF of it, so that should give me the pinout of the coils. So it looks like. Let's strip these real quick. So I gotta find which ones are the AB pairs and then link them together. Okay, so there is A and C, black and green. Black and green are a pair. I cut the wires. Yeah, I'm making my own wires anyway, so don't worry about that.
By the way, Ponymaker is not responsible of whatever's gonna happen.
Oh, interesting. Okay,
So
not connecting them, it moves typically like free.
yeah.
And I connect the black and the green together.
Okay, so
So
it
I'm
seems that there is
shorting
some.
out the one of the coils, and now there's a lot more resistance. It's like almost hard to turn. And if I short these out, oh, it's completely locked. It's
Oh,
super hard to turn. like, well, it's not locked. Oh, it spins smoothly. Yeah, I can't feel the steps.
It's completely even now. Maybe this
Yeah, it's
completely
even.
even. Oh, and so that means when you say you're short, so I can see on the diagram there is phase A and phase B. So you put the two B together and the two A together, right?
Yes.
Oh, okay. And then okay. So
So
why, why does that? Because yeah, there is a question of evening everything out, but why does that create resistance?
because this is a uh, fixed uh, uh, fixed mag. What do you call this type of motor? The magnets are stationary and the coils move, or
Because in
well,
order to create the field, you need some movement. Like even if it's a resistant field, then you need some movement, right? So
right,
you should
right.
be able to
Movement
move.
creates energy, and
Yeah.
if there's nowhere for the energy to go, or I don't know what's the science here.
Okay.
How does this work?
Caleb, it has to do with the physics of motors. Short version, you're using the motor as a generator and giving it at a very high load.
Oh, okay. Yeah, you have an infinite resistance now because it's a short circuit.
Oh, so which means, oh, basically, so now you have a generator. Okay, yeah, I get what you mean. So if you're forcing it, then you're actually creating electricity. I mean,
Right.
creating currents.
Okay.
Okay. Uh, let me think a little bit more. Okay, so, oh, yeah, oh, because, well, let me think.
Yeah, it's getting a little late. It's like midnight for me, so my brain's starting to stop working.
Yeah. Sunaz, it's all just blue magic, shenanigans. To me, I just know it works. Yeah, it's well, at least it's interesting to know how that thing is working. So then yes, it would work offline. Then I mean
Yeah.
off
Yeah,
power.
that definitely would work.
Okay, interesting. I
So,
still don't get it 100% on why it's blocking it from turning. But yeah, we can do some further investigation. Short circuit is very low resistance, allowing a large current to flow through the wire when it moves. Yeah, the only
okay.
thing I don't understand so much is even the small movement is very hard. So it means even the small movement is already creating that energy that, you know, yeah.
Yeah, no, I get it now. I get it. So I said that wrong. It's a short circuit. So there's really low impedance in the coils now.
Yeah,
So a
yeah.
small movement creates a very large amount of current, or it takes, yeah, and the more current you try to create, the more force it takes, the more energy. So the harder it is to move, the more resistance there is in the magnet.
So okay, so when you're going to spin, then it will create a current. The current will feed the magnet, and which is going to block you from turning. And then that's the loop that, and then the faster you wanna spin, and the more energy you create, the stronger the magnet become, and the even harder it is to spin. And that's the loop, right?
Uh, Sort of. It's there's an induced magnetic field to resist the rotation. You're well, when you spin it, you're making a change in the magnetic field, and that change is um, characterized by how much impedance there is on the coil. So the more impedance, the more resistance there is, the easier it is to turn because it's not making enough as much current. AKA, there's not as much energy transfer. But if it's a short circuit, there's a lot more energy transfer.
Yeah, but there is something that is blocking you from turning, and that has to be the magnet, right? It's not the fact that you create a current that is blocking you, I guess. It's like something physical, like the magnet that are blocking the rod from spinning.
Yeah. Well,
The bigger the change, the more
it's the
current.
fact that you are making power, or you're
Because
trying to you're trying to make power, but it's resisting because of how it's generated.
yeah,
Electric current creates its own magnetic field. Right, right. A motor is a generator, so you can feed this with electricity and then make it spin, or you can backfeed it with motion and make electricity.
yeah, yeah, yeah.
Guys, I don't want to talk about flux. I'm not talking about flux.
Magnetic induction or
No,
flux
I don't want
field.
to go back to those days.
Oh, actually, yeah, that's you are a good you have a good background to explain us on this type of things.
Right, but like I said, I don't like flux. I like transformers. I can tell you all about transformers, but I I don't like the or I'm not as knowledgeable behind the science. I like it. I just there's a lot to it. It's very, very, very scientific. Yes, we're talking about EMF or maybe
Just
like
catching, yeah,
flux.
you.
B.
It must be funny for someone that yeah, just go for a coffee and then we were talking about printer stuff. Yeah.
The calculations are painful. Yes, yes. That's why I don't want to. I'm scarred. I'm scarred by the calculations. It is not fun.
Um, okay, so I think that was for the motion transmission. So we
Yeah.
were talking about yeah, the ball screws, and then yeah, just to link that to what we're talking about right now. I think the last one is movement system, but how about we keep that for another stream, because I think that element itself is I think there's a lot to say. I mean, I did spend almost 2 hours just on the core XY
Yeah. I mean, there's
stuff.
not a ton to talk about for like the traditional stuff, but there's a lot you can talk about.
Hmm. Um, so yeah, thank you very much, Zombie, for sharing all of this knowledge, and I really like the fact that you made live experiments. That's pretty nice. That's the best way to understand things around us, right? You just get it in your hand and then play around with it. And apparently, you also discovered something, which is the goal, right? We're all
Yeah.
learning.
I'll
So
answer answer Michael's question real quick. He says, "I have an off-topic question. If I built a 3D printer from scratch, how do I get it to work? Is it as simple as customizing firmware like Marlin?" Um, there's a lot to it. You need to select all your components. So everything we're talking about today, you need your motion system, the guiding system, the actual type of motion, and then you do need a controller that's configured for that motion system. So yes,
cool, cool. Um, well, again, people in chat say thank you to Zombie for sharing all of his knowledge. Again, Zombie is on Twitch. I don't know if you have a particular schedule at the moment on Twitch, Zombie.
I've been trying to stream around this time, so I would
Okay,
probably be streaming right now, putting together. I'm trying to fix up this printer, so I was gonna do that on stream.
okay,
Let me link my Twitch again. You can follow
yeah.
me.
And then yeah, so if you enjoy this kind of hardware topic, then feel free to go on Zombie's Twitch, follow his Twitch, and then once he go live, then you can bombard him with all of your hardware questions, and and get a nice vibe on his stream. So yeah, thank you again, Zombie, for joining today's stream, and then let's do a follow up for the last element of that Printbuster topic.
Sounds good.
Awesome. So yeah, I will somehow remove it from the
I don't know which
studio.
tab I'm in. Real
Kick.
quick though,
Yeah,
everyone go and buy Galaxy Dark Blue. Galaxy Dark Blue. Go buy it. Go buy it. Go buy.
it was coming. See you, Zombie. Bye.
Bye.
Okay, so I used the kicked out way of doing. I don't know if it's the best way of removing someone from the stream, but yes, bombard him with flux stuff. Yeah, it was a very nice stream today. Having Zombie on stream explaining the hardware stuff. We should do that. We should do that more often. If any of you have specific knowledge to share, I mean, I know most of you, are spending no flux or ban. If any of you have good knowledge about something, it doesn't have to. You don't have to be expert in something. You just have to know, more than the average, so that whatever you're going to share will be, will be a learning process for all of us. And believe me, I don't know much, so most likely whatever will be something, a new learning for me. So great. I didn't realize there was a giveaway. Yeah, we have a small giveaway every stream. So a lot of new skills I learning. Yeah, I hope a lot of good learning for all of you, and we'll continue like this. PRINTBUSTERS topic are about learning in depth 3D printing related phenomenon or any kind of topics. Making a speaker driver. I got some questions about EMF and flux hedgehog. How do we get in the giveaway? Oh, sorry, I forgot to put the banner. But basically, you just have to be awesome to be in the giveaway. That's it. Here's the banner. Just be awesome. Dive into the science of 3D printing and build our knowledge one layer at a time. I really like this. That also came from our community. Builders Mark, you sent a few DMs. Yeah, I will have a look at this, and I think 3D HP. I need to have a look at some of the message. Caleb, it'd be interesting to learn about ABS vs ASA from your perspective. Yeah, we do have a Q&A session on Tuesday where I'm talking about more of this kind of questions. So okay, let's do the giveaway to close this awesome live stream. So 24 viewers, 33 entries. So I guess everyone is in there. So we're going to draw in 5, 3, 4, 2. Oh, just in time, Sophia. 2, 1. There you go. Drawing. Today's winner of this awesome stream with the very first guest on PRINTBUSTERS is just me. It's just me. I'm the winner. So just me are still here. Caleb, I'm awesome. Not true. Yeah, you are. You are, Caleb. Congratulations, just me. Just congratulate me. Are you still there? Fell asleep. Just me, you have 10, 9, 8, 7, 6, 5, 4, and then I draw again. 3, 2, 1. Oh my God! At the last second, just me. Did you make it on purpose or what? Or I didn't see your message before? Maybe I didn't see your message before. But anyway, fortunately, you wrote it 2 times. Just me responded. Yeah, sorry. I don't have. I didn't see that. Congratulations, just me, for winning a spool. You can contact me at this email or on Discord, and then I will send you a link for that. He was here since a while. Yeah, sorry, I didn't see that. So again, thank you very much for joining this 7 episode, I think, of PRINTBUSTERS. A lot of great learning. Thank you to Zombie for sharing all of his knowledge and answering our question on the motion system topic. And then I think he will be streaming now. Let me check. Oh, maybe he's not streaming right now, but he's He's usually streaming about that time. Oh yeah, he say it was midnight around where he is. So most likely not today. But yeah, thank you again, everyone, and then I will see you on Saturday for on Twitch. Oh, by the way, this is the last time we stream on Twitch on YouTube. So I finally made the decision, and then we will move all the live stream on Twitch. So I hope it doesn't affect some of you. If you don't have a Twitch account, it's very easy to create a Twitch account. There is a wonderful community on Twitch. So I hope that I will see all the same name here on Twitch, and I hope we are not going to leave anyone behind on YouTube. So I will see you guys on Twitch on Saturday for Polymaker Academy, which is also about learning. Whatever stream is about learning. Okay, have a good one, everyone.